Thank you. Good afternoon, everyone. SCR systems have been widely used for a long time to reduce diesel engine emissions. Nevertheless, low temperatures are an issue as they cause the DEF to freeze. Imagine if we could use sensors and devices that don't break down and also operate in such conditions. These solutions are already available. These are HealthTech in-ice solutions. In the following presentation, I'd like to speak about our approach to emission control, our in-ice technology, that is sensing, smart heating, integration, a few words about future steps, and in the end, a quick overview about what HealthTech Group does. Our approach to emission control. DEF is really an harsh media, but it is something we got to manage thanks to our 15 years long experience. We began in 2001 with the first product. It was a connection module for truck application. Then, step by step, facing the problems related to DEF, we had the opportunity to develop a portfolio of solutions with unique characteristics. These characteristics we call these characteristics in-ice features. Then I can remind the first product in the market that was in 2005 the temperature sensor, then the pressure sensor in 2008, and the next ones will be level sensor and quality sensor. To develop a reliable automotive product, a scientific approach is needed. For this reason, we have been working with universities, external research centers, and we have in-house R&D capability. I like the fact that we have a possibility to develop novel materials thanks to our expertise in nanomaterials and nanotechnology. Now we can start to speak about our sensing devices for SCR application. Our sensors are covering a wide range of sensors needed from SCR systems, like pressure and temperature, level and temperature, quality, and the combined one, level plus quality plus temperature. As I said before, every product has got a specific characteristic that we call in-ice feature. The pressure sensor has got the characteristic that it does not break even at minus 40 degrees. Even if our sensors are responding to market demands in terms of performances, we keep on working on our roadmap to develop the technology of the sensor and to reduce both cost and size. This year is in the market the generation 2 of the sensors, that it is basically the integration of the electronic over the ceramic itself and the introduction of the digital send output. The generation 3 is in development, and the focus is mostly on reducing the size. Gen 4 is in research. Some data about our pressure sensor. We can proudly say that 15 million vehicles are equipped today with HealthTech pressure sensors. This year we are going to produce more than 4 million pressure sensors for this application. It is suitable for not only for passenger cars and truck application, but also for off-road. And it is available today with both analog and digital send output. Thanks to the digital send output, we have also put in the market this year the combined version pressure plus temperature. Some our data are that it is compliant to requirements for automotive markets and requirements coming from OEMs. I'm speaking about OBD2 and about EMC and ESD characteristics. It has been approved with 3 million pressure pulses, 0.15 bar, with DEF at 80 degrees, and with 500 thermal shock and 1,000 freezing cycles. It has been approved also from the mechanical point of view, but among these data, I would like to highlight the fact that it has been also approved with 4,000 hours in DEF at high temperature and 5 bar. Now I can speak about the level plus temperature sensor. When we began to develop this sensor, we took in account the limitations of the existing sensors in the market, such as ultrasonic, radio frequency, reed switch. The nice feature in this case is simply that it can measure at every time, also even in frozen DEF. To explain better this characteristic, you can look at the pictures that we have in the presentation. So you can see that the level sensor is able to measure when the fluid, the DEF, is completely fluid or completely frozen, or when there is a mixed phase between liquid and frozen DEF. It is also able to detect the level of the stratified things. So when we have, for instance, ice, liquid and ice, or even if when there is air of air inside, so when there is a cavity of air in between. It is also able, and this is, according to me, a quite important characteristic, it is also able to measure the refilling of liquid AdBlue on the ice. Fluid sloshing can be measured by the sensor. We can produce a digital filtering in the sensor in order to avoid to have a stable measurement of the level, or we can go outside the sloshing, the movement of the liquid inside the tank, according to the customer OEM requirements. The principle is an innovative contactless capacitive measurement. We have basically a multi-electrode layout on the PCB. Every electrode is like a capacitor, and it is able to understand when there is an electric field change. We can say that in presence of liquid or in presence of air, the electric field can change, and we can see it. The sensor is available in different lengths, and it has been tested for several things. For instance, is not affected at all by DEF conductivity, by DEF concentration and density. It has also been tested, and we know that it is not affected by air bubbles. Another important characteristic is that we don't have a blind zone. So let me say the first pad is also the first point where I begin to measure. So I can really measure the bottom of the tank. Then there are other characteristics, the standard things. So we are according OBD2, and we have several kinds of output like cent, lin, or can. The resolution is plus minus 2 millimeters. And auto-diagnostic features are included. Operating temperature is from minus 40 to 80 degrees, and it is also designed according to automotive requirements for overvoltage, inverse polarity, and ESD protection. Now we can speak about the assembly of the sensor. It can be bottom-up or top-down. From the fixing point of view, there are several solutions. We can use bayonet, screwing, or welding because the material of the sensor itself is HDPE, so we can direct produce a welding with the tank. Now, I'd like to speak about our quality sensor. The main feature is that it can work with a very thin layer of DEF. So it means that we have, again, basically no blind zone. So we can begin to measure when the level of the AD blue, of the depth over the sensor is very small, a very thin layer. The sensor is based on critical angle detection. The concentration changes the critical angle, so we can recognize the concentration by means of the critical angle detection. Accuracy of the sensor. We have tested the sensor, and now we can say that the end-of-life accuracy is less than 2%, from 20 to 40% Ura in water. I'm speaking about the concentration measurement. About the temperature measurement, the accuracy is plus minus 1 degrees, from minus 40 to 85 degrees. Resolution is 0.1% for concentration and 0.5 degrees for temperature. The sensor can also detect the tempering. This is very important. And another important characteristic is that it can measure not only in static condition, but also when the fluid is in dynamic condition. So some other indications are about the output signal that can be analog or sent or digital. The supply voltage can be 5-volt regulated, standard, coming from the ECU, or both the voltage coming from batteries, 12 volt and 24 volts. It has been already tested, as I said, with 400 thermal shocks in air, and with 2,000 hours per mission in DEF at 80 degrees. It has also been tested for the inline assembly with up to 80 bar. So this is a picture that describes what happened after these bullets that you see are all the accuracy we find out after all the tests we did. So we can say that after the lifetime test that we did, all the sensors are clearly inside the accuracy requirements of 2%. Another important point is the sensitivity to the turbidity, and we tested with Arizona dust fine according ISO 7027, and we are again clearly under the 2% that it is the accuracy of the sensor. Now I like to speak about the assembly. It is suitable for in-tank assembly by means of screwing, by means of hot plate welding, by means of bayonet. It is also suitable for inline assembly. I can say that we have a collaboration with a company that is a well-known company in the SCR field, and we are developing together a quality sensor with integrated heated pipe. The combined sensor, level plus quality plus temperature, responds to the need to integrate more function in one housing, reducing both size and cost. The nice features in this case are the same that I've already described before when I spoke about level, quality, and quality sensors. Now I go to the SCR smart heating technology. It is basically based on our research that we have done on nanomaterials. So we basically have produced a plastic PTC material that can be overmolded, can be molded like a standard thermoplastic material. Thanks to this fact, we can say that it is moldable in countless shapes. he has got a local PTC effect and a high power density. A few words more on the local PTC effect. It means that if a portion of the heater is not inside the AdBlue, this portion of the heater is producing a self-regulating themselves. So the current is going down, the resistance is going up in the zone that it is outside of the liquid. So, thanks to the fact that I have already described the way we can produce the parts, we can have a distributed heating, we can have a very good and efficient thermal exchange, and the power density that I said is very high is up to 1 watt per square centimeter. Sensing integration and future steps. We have just described the possibility to produce a plastic flange with our PTC plastic material. So imagine what we can do. We can use this plastic flange, self-heated, and integrate in this plastic flange all the sensing function that we have seen before. So we can have a self-heated plastic flange with a level sensor, quality sensor, temperature sensor, and pressure sensor. This means high integration and also system responsibility for ELTEC. We did the benchmark on this product, and we have estimated a quite big cost reduction coming to this integration. Future steps. We would like definitely keep on working on sensing integration. This is one of our targets. Another very important point that I would like to highlight is the possibility to use our in-ice solution for our application. For instance, for water injection. You know, in this case, we are using not DEF, but water. But you can imagine that the freezing problems, freezing issue related to the water can be still worse than the one related to the AdBlue, because the water freezes at 0 degrees, not at -11. So we think that our sensors, our solutions, are already suitable for water injection application. We are also working, speaking for our points for future steps, we are also working on fuel cell devices and on e-vehicles devices. So, at the end, I would like to conclude giving you a short overview about of what ELTEC Group does. ELTEC Group was founded in 1979. We produce a turnover, aggregate turnover of more or less 150 million in 2015. We are 1,200 people, and we invest every year a big amount of our turnover in investments. We have also a big focus on intellectual property, and we have more than 600 patents. Certifications are the one that you know very well for not only for automotive application, but also, for instance, for medical application. Even if automotive business unit is the main one today in ELTEC, ELTEC is not only automotive, it is also appliance, sensing, medical, and biomedical. We can say that we have a worldwide footprint with 3 R&D centers, with 7 sales and plant all around the world, and with 2 sales offices in Germany and USA. So, ELTEC in-ice solution don't break down, can work properly in any condition, and allow the CR systems to hit the target in terms of emission reduction. Next point is the Q&A.
Thank you, Mauro. So that was a very quick presentation comparing to the others we had before lunch. And we have 10 minutes for question and answer session. And the floor is yours.
I can add also that we have a booth here, so we have time later to speak directly if you want.
So no question from the audience. I thought that was very good. From my side, I have no question either.
Okay.
Thank you very much. Thank you.
Thank you to you.